Hello everyone, today I'm going to go over the adapter pattern. This pattern is used when you have multiple different incompatible interfaces. You want to put them together without modifying all of them. A good example is thinking about if we had some sort of media player class. This all it does is just have a play method, or think about like a play button. If we have this media player class, we're going to have different third-party libraries. Maybe we have one with a YouTube player, one that has an MP3 audio library player. But if we think about each of these libraries, they each might have their own different implementation or their different way that they execute. Maybe the YouTube library uses something like a play movie method or play vid method, or the audio library uses play music. If we want to use all of these interfaces together without having to modify them, then we can use this pattern to solve that specific problem. To be more clear, we want to go ahead and think very carefully about, we have something like an audio text reader class. The whole application is wired to call specifically that reader play method. That play method is going to have just one specific method, same signature. It's supposed to be very clean and unified interface. What we do though is underneath we have another method that we use, like the play vid method, which has the file name, but there's no play method there. And we might also have something like the MP4 player, which also has the play music method. If you want to, and we might have totally different method names, totally different signatures. So using both of these different methods and classes together, we can try and use the play method and use if statements everywhere in the code. And we could possibly modify the third-party classes themselves. If we think about it, both of those approaches are fragile. They scattered the knowledge around about the incompatible interfaces throughout the code base. It also breaks encapsulation. We want to think about a better way that we could do this. The adapter pattern is one of the classic Gang of Four structural patterns. So the definition is we convert the interface of a class into another interface the clients will expect. Adapter lets classes work together that couldn't otherwise because of incompatible interfaces. The keyword we have there is structural. A structural pattern means it is about how the classes and objects are composed. It's not about adding new behavior. The client doesn't know that it's talking to an adapter. It just knows that it's holding a media player class and it's calling the play method. The adapter is completely transparent. There are actually two different kinds of adapters. We have class adapters, which use inheritance, and then we have object adapters that use composition. So in Typescript and in this repo, we're going to use the object adapter style. The media class will hold a reference to the adaptee rather than inheriting from it. Here's the structure diagram for our demo that we have here. We have the target. We have four roles in this path. We have the target, that's the interface your client code depends on. We have the adaptee, that's the existing class with the incompatible interface. We have the adapter, that's the bridge that implements the target and wraps the adaptee. And then we have the client, that's the code that uses the target interface. In our demo, the media player class is the target interface. The advanced media player is the adaptee interface. The media player is the adapter, and the audio text reader is the client. Notice that the adapter implements the target, and it holds a reference to the adaptee. It's doing double duty. It speaks the language the client understands, and it knows how to talk to the adaptee. If we look at all of the participants that exist in the repo, we have two interfaces. The media player defines the target with a single method. play method, which uses a media type and a file name. And this returns a string. That's it. That's all the client cares about. The advanced media player class defines the adaptee's incompatible API. This is the play vid method for video, and then the play music for audio. Two separate methods, no unified play method. Then we have two concrete adaptees. We have a YouTube player class, which implements the advanced media player class, but only does something meaningful in the play vid method. The play music method is a no-op, and the MP4 player class, which is the inverse, only the play music is meaningful. The play vid method returns an empty string. The media player class is the star of the show. It implements media player. The media adapter is the star of the show. It implements the media player class and wraps around one of the two adaptees, routing play method to the right method based on the media type. And finally, the audio text reader class is the client-facing class. It implements media player class 2. It handles text files natively and delegates everything else to the media adapter. There's also a smaller example in the payment domain. If we look at the bank details class as an adaptee, the bank customer as the adapter that will make the bank account data look like a credit card. But we'll focus just on the media player for this walkthrough. Here we have the target interface. This is the media player interface. So media player interface, this is what the entire client side of the application cares about. There's one method and two parameters. It's clean. That's the contract every participant is expected to honor. Notice it returns a string. In this demo, that string is the result message that gets rendered in the UI. That's a common pattern in browser demos. It returns the result rather instead of a console logging it so we can display it in the DOM. Here we have the advanced media player class, the incompatible interface that already exists out there. There's no play method, different method names, different shapes, different API design philosophies. These two interfaces cannot talk to each other directly. Someone needs to translate between them, and that someone is the adapter. This is where the magic happens. Let's look at the media adapter. Two key things here. First, it implements the media player class. So to the client, this is a valid media player. Second, in the play method, it translates the unified call into the appropriate method on whichever adaptee it is wrapping. So the play method YouTube becomes play vid, and the play method using the MP4 argument becomes play music. Translation, it's not behavior. Notice the adaptee class property that's exposed so the UI can show which concrete adaptee was instantiated. Not part of the core pattern, it's just a nice touch for the demo. And here is the audio text reader class. This is the client class. For text files, it handles them natively. There's no adapter needed, just reads directly. For YouTube and MP4, it creates a media adapter class and delegates. The caller of the audio reader class always calls the play method. It never needs to know whether an adapter was used underneath. And that's the beauty of it. The interface to the outside world never changes. The adapter is just an implementation detail. Here we have the adapter demo. Again, the first thing we want to think about is this is the client here. This is the part that we're interacting with the most, the audio text reader with the play method. Here, it connects to the media adapter, and through the media adapter, it will interact with both the YouTube MP4 adaptee libraries, so third-party libraries that have these different methods that we're not able to technically use directly or modify directly. We connect through this adapter to be able to use these two different libraries. The first thing I want to talk about is through this demo, we'd be able to see this call chain. If it's a text file, then there is no adapter. This class just reads it directly. It will just go to the text and will output it. Nothing really happens. If it's a YouTube player file, we want to pretend that this is going to play this file, and through that we go through the media adapter that will have the same play method as the audio text reader, and through that play method we're able to call on to the YouTube player to play the video, which will stream that video. If it was a music file, MP4, we do the same thing. We'd able to play it through the audio text reader, go to the media adapter, do the same method play, and through that connect it to a separate MP4 player library. The first thing I want to look at is going into the Typescript here. We have first this audio text reader that we're calling in. We have all these different files that we're using and we're playing in this audio text reader class. And every time we play those files, we have to connect to the file type, the file name, and then through that we're able to call the play. The first thing we want to look at is the audio text reader. This is the client and the target. Through that, we're just simply using the play method. If it was a text file, we just return the text file. We're able to quote unquote play it. Nothing really happens here. The last adapter is null, just return that. If it's either a YouTube file or MP4 file here, that's when we can instantiate the media adapter to play from these two separate libraries. The media adapter will be the same thing as the audio text reader. Both of them are implementing the same interface. This is the play method. Through that, though, they both have different of this, the advanced media player, which the advanced media player itself is also just having two methods. They have the methods of the separate libraries and classes that we need to call. From this, we're able to create this connection between the advanced media player and the play button here. We actually can create a better separation from this adapter as we use this constructor to change the different adaptee based on what the media type was. For example, we have this file type that will change from YouTube, MP4, and text. We will play it, and through the play, if it's not a text file, we will play it, but every time we play, we will create a new media adapter that has either a YouTube player or MP4 player, and both of these will have an implementation of the separate individual method that's not really connecting with the other method. Basically, they're all separated, or they might have their own unique implementation. Like this play vid will quote unquote play the video. If it's the MP4 player, instead of a play vid, it's not implemented, so we have this play music that does that instead. This connection first between we play it, create the new one, the media adapter will have its own individual advanced media player, and from there we can just click play from the audio text reader here that we can execute the underlying method, which would be either play music or play video. A big benefit to this is creating a total separation between all of the classes and methods. We can kind of modify and expand. And we do not have to manipulate anything more than just creating that class and just using that method. So that's a big benefit of having the adapter be calling and creating those separate libraries. When we want to use the adapter pattern, we have three key scenarios. First, we want to use it when we have an existing class, maybe a third-party library you cannot modify, but its interface doesn't match what your code expects. So that's the classic use case, exactly what we saw during the demo. The second one is when you want to create a reusable class that needs to cooperate with unrelated classes that have incompatible interfaces. You write once to the target interface and then write adapters to each incompatible class. And third, when you need to use several existing subclasses but can't add new code to every one. You adapt them at the object level with a composition-based adapter instead of changing every subclass. Here we have some examples on when you don't want to use the adapter class. If you own both interfaces, you can refactor one of them instead of adding this adapter layer. The best adapter is actually using no adapter. Adapters add indirection. Every call will go through one more layer of delegation. In hot paths, that processes thousands of calls per second, so that can make a difference. Profile before adding adapters to performance critical code. We don't want to chain adapters. If you find yourself adapting an adapter to adapt another adapter, you've lost the plot, so you have to step back and redesign the interface. And don't use adapters as a band-aid for bad initial API design. If you're writing adapters for every single class in your code base, the problem becomes an architecture problem, not incompatibility. There are three real-world analogies that might help understand the adapter pattern. So first, let's think about a travel power adapter. Your laptop expects a 120 volt US socket. The hotel in the UK has a 240 volt British socket. The travel adapter converts between them. You don't rewire the hotel and you don't rewire your laptop. The adapter is the translation layer. The second one is thinking about card readers. Your SD card has a specific form factor slot. Your laptop only has a USB-C. The card reader will wrap the SD card and present a USB-C interface to your laptop. Here, the laptop is the client, USB-C is the target interface, the SD card is the adaptee, and the reader is the adapter. And third, we have database drivers. Your application expects the standard JDBC interface. There's one query method, a standard connection string, but Oracle, MySQL, and Postgres all have completely different native APIs underneath. The JDBC drivers are adapters. They translate the standard target interface into each database's specific native calls. Here we're going to compare between other related patterns. The first one is the decorator. This one also wraps around the class, but its intent is to add new behavior responsibilities at runtime. So the decorator preserves the interface. The adapter will change the interface. If you're adding logging or caching on top of an existing class with the same interface, that would be a decorator. If you're translating between two different interfaces, then that would be the adapter. Here we have the bridge pattern. The bridge pattern also depends on two things, but it's a design time pattern. You design your abstraction implementation hierarchies to be independent from the start, so both can vary independently. The adapter is typically a retrofit. This means you discover an incompatibility after the fact, and then you'll bridge it without having to change existing code. And then finally, we have the facade. This one gives you a simplified interface to a complex subsystem. The subsystem's interface doesn't have to be incompatible. The facade is about simplification. The adapter is about interface translation. A facade might use an adapter internally, and that's totally fine. They're complementary. They're not competing. To summarize, the adapter pattern wraps an incompatible class in a new class that speaks the interface the client will expect. In this repo, we had the media player class implement the though the media adapter implements the media player and wraps the advanced media player, translating the play method into the play vid or the play music method, depending on the media type. The audio text reader class only ever calls the play method and doesn't ever know which underlying player was used. We use it when you can't modify existing classes, but need them to both work with your interfaces. You avoid it when you own both sides of the interface, when you own both sides of the mismatch. So here you can just refactor instead. That's the adapter pattern. If you want to dig deeper, you can just watch my other videos or go through the code, go through the repo, read the documentation. Here we can just work on maybe adding or modifying the demo space that I have already. I'm going to be continuously working on these patterns, especially the structural patterns. That's my next videos. We have the bridge, composite, decorator, facade, flyweight, and proxy. So each one will be a demo in the repo, and I will link them to the description. If this video helped you, if you can drop a like and subscribe, it really does make a difference, and hopefully I will see you next time.